Okay, so hi friends. As we can see in the screen, like today we'll discuss about the API gateway basics. So in microservices, we'll have a lot of microservices we'll develop one by one. So how client will call the those microservices instead of calling directly the microservices, we use a API gateway basics like API gateway service, which will work as a gateway for our all the microservices. Okay, so when we are creating our application, that application will consist of multiple APIs. Instead of calling those multiple APIs directly, we'll use a extra layer that will say like gateway layer, which will have certain features. uh, Eventually all those calls from client it will go through the gateways. Okay, we'll discuss in the next slide that what are the benefits we'll get and why we are using all these things, what are the uh, commonly used API gateways are there. So, okay, we'll go one by one. So, as we written here, an API gateway is the single entry point for all the client requests in a microservice architecture. I have explained already, like in a microservice architectures, we'll have a extra layer that is a gateway layer, and we'll discuss like what are the benefits of all those things. Instead of client calling each microservice directly, every request first reaches to the API gateway, and from API gateway the call will go to the particular called APIs. Okay, okay. So this is the API gateway, how it will work, like where it will exactly fit into our microservice architecture. So above that client will be there. When the call will come from client, it will go to API gateway. Then these are the services. Suppose we have user services, order services, payment services, validation services. So all those things will have will create a lot of services. Then all those requests will come through API gateways. Okay, why we need these things? Without gateway, what happens? Like client, it will directly call user services, then order services. It will call directly the payment services, notification services. What are the services we will have? It will call directly from the client. It will come. So what are the problems will come if we have this kind of thing like without API gateway? So client must know every service URLs. Okay. So client has to know when it will, how it will enter. Like he has to know the URL of each and every services. And the authentication, mostly we need authentication for our services, and for each services we have to implement that authentication logics and authentication processes for each services if we are not going for the gateway services. So as all the requests will come through the gateway, so we will have in one place all the authentication will happen in gateway layer, and then it will come to the other UPI URLs. Okay, no centralized logging. There will not have a centralized logging. We have to give those logics to all these services. No rate limiting. We cannot give the rate limiting. How we'll do the rate limiting? Or that then that will again it will be duplicated. And the version management will also be difficult because each service will have a lot of versions, and managing those versions will be very difficult. Those things we can do in API gateway, and also the SSL handling will be difficult if we have the gateway layer. So what will happen, like client, then API gateway, then will go for other services. And what are the advantage we will get here? So a single endpoint will have only one endpoint, and from that endpoint it will go, the request will go to the other services. Authentication will be centralized, routing also will be there, load balancing will be there, monitoring will be there, then security will implement in gateway, logging will be in one place, and rate limiting will be in one place, and also we can implement the caching. So what are the commonly used API gateways we have? Like here, we have many API gateways. A few are mentioned here, like Spring Cloud Gateway, Kong, Snakes, Apache API 6, Traffic, Envoy Proxy, Istio. So many more are there. So next one is Amazon Web Service API Gateway, that is mostly used when we go for that AWS cloud, microservice Azure API. So when we go for Azure cloud, and when you use GCP, there also we have Google Cloud API Gateway. So these are like the commonly used API gateways, and we have all these details here, like language which API gateway will have. So those are also mentioned, and those are commercial or open sources. So these managed means, like suppose we use Amazon Web Service API gateway, so that is fully managed by AWS. So that will have those are not open sources. Okay, then we'll go to the next slide. So I'm just highlighting few things here because the video will be very long. Uh, so the Spring Cloud Gateway, the most popular API gateway in Spring Boot. It is built on Spring Boot, Project Reactor, and Native. It is fully non-blocking and a reactive gateway. So currently, mostly as we are using the Spring Boot applications, so we very commonly used gateway is the Spring Cloud Gateway. Then, as we know, AWS is used almost everywhere. So for though that the gateway AWS API gateway we use, this is a fully managed gateway, and the features are like the Lambda integration is there, authentication is there, API keys are there, like we'll have API keys for all APIs. Then throttling is there, monitoring is there, WebSocket APIs are there, and this is best for AWS native applications, like when we are using AWS, this gateway you can use. So this is the typical microservice architecture. Here it will have the internet, then we'll have load balancer. It will useful for scaling. The multiple instance will be there, which will serve for the request. Then we'll have API gateway. Then our particular services, what are the services we'll have? Those services will be there in a one layer, and those are connected to the databases. So for this, what are the Maven dependencies will be there? We have to add Spring Framework Cloud and a Spring Cloud Starter Gateway if we are using Spring Cloud Gateway. Okay, this is the Maven dependency, and the YAML file will be like this. We have to mention all these things. Then gateways, you can see Spring, then Cloud, then gateways. How it will routes, like ID will be user services, name will be here. Then URI will be what are the URLs we have, we can mention there. Then predicates, like how the path will be, and based on these things it will create the URL. ID orders, ID, what will be the ID, like for order service it will be for this user service, this will be And for order service, these are the parameters will be there. And for payment service, these are the examples I have mentioned here. So based on this, it will create the URL. Okay, how it works? Like as I told in the previous this one slide, so it will take the port, the HTTP and all those things. Then uh, it will create the URL like this. So gateway checks the path. It will client request, then it will get then gateway checks the path users which we have mentioned here in this path equal to users in that pattern. Then it will matches. Then forward the request to localhost 8081 users 10. So client network knows the user service URL, which will be the user service URL because the pattern is matching. Okay. So one more thing is like dynamic routing using service discovery. So this will be like instead of hard coding the URLs like 8081, 8082, 8083, we will register all services with a service registry such as Netflix, Eureka, and that will get to become like this. We are not here, we are not mentioning all these the URLs, localhost and colon, the port numbers. Instead of that, we are doing like this, mentioning the ID. URI will be load balancer, LB is load balancer, colon, double slash user services. Predicates will be like this, the path pattern will be users. And for order ID, it will be like this, order service, then predicates, then path. Okay. The the LB means the load balancer. Gateway automatically finds the available instances. What are the instances? We'll have for the availability of the application. We'll have multiple instances, and based on this, it will find the up and running instance. So that is the work of load balancer. One more thing is that the component is gateway filters. Filters intercept the every request. Like when the request will come, it will intercept it, and the process is like the client. Then it will have the authentication processes using the JWT token or something, and then logging. Then it will have rate limiting. Then we'll have routing. Then the microservices. Filters are similar to servlet filters, how we use in servlet, the applications in struts will have used the filters, and and these are used, it will be like the servlet filters only, and designed for the reactive applications. Like nowadays we'll have all these applications here. So built-in filters, these are the things like add header. If you want to add the header, the filter will be like this: YAML file, filters, like add request header equal to x hyphen app, comma my applications. Remove header will be remove request header authorization. Rewrite path will be like this. Incoming will be like this, and forwarded will be like this. Then configuration. In YAML file, we'll have this kind of configurations. Filters, we rewrite path equal to slash API slash the segments will have, and what are the things like users 10 we are passing here, like it will be like this only. And the prefix path we have to define like this. Incoming will be like users. If it will get the in the requested users, it will forward to API and users, right? The YAML filters will be like this: prefix path equal to slash API. So it will add the, it will get slash users, it will add slash API into that. We can also custom that one like this. The sample code is here. Like we'll have a component, and we are making this filter as a logging filter. Extension abstract gateway filter factory logging filter dot config. We are that is the type here, and these are the methods like logging filter and super config dot class. It is calling that constructor, and that override that method gateway filter apply will be like this. We are passing the configuration file configurations here. Uh, so it will mention like this return the chain filter dot action. This is the sample one only, and use it here like the YML file will be like this. We have to mention the filters logging filter that this filter will be to activate this one. We have to mention that this like filters column below that it will be mentioned in the YML file. JWT authentication filter, how it will be like the flow will be like this. Client, then authorization, where JWT token will be there, then gateway, then validate token, and forward requests. It will request the forward after validation and the microservices. If token is invalid, then 401 unauthorized will be there. Okay, global filter runs for every request. Like you, instead of mentioning one filters for every request, it will be globally. We can define that one. So this will be like this. Um, we have to implement that global filter one, and the method will be overridden. Uh, so these are the super web exchange is equal to exchange gateway filter chaining, and it will be return the exchange one. Okay. So rate limiting, how we are adding the rate limiting into the API gateway. What the use of that rate limiting is like how many requests we are serving for that. So particular service will serve how many requests. So it protects services from excessive requests. Like lot of requests are coming. So how it will control that? That is the rate limiting. User request 100 requests per minute. Allowed 10 first requests. 429 too many requests. Spring Cloud Gateway supports rate limiting using Redis. So the YAML configuration will be like this. The earlier we have mentioned that, right? So name will be mentioned here. Request rate limiter. So circuit breaker configuration is like this. It will come to the gateway, then payment service is down, then fallback response. So circuit breaker commonly, we know that, right? Commonly via resilience 4J, we use it for repeated failures handling. So if the payment service is down, it will go for the fallback responses. So that the earlier service circuit breaker we have written, right? So that will be in that exam YML file we have to mention like this. So it will work for that circuit breaker pattern will work. So completely request flow will be like client. From client it will go for API gateway, and there it will be like authentication filter, logging filter, rate limiter. All these filters will be configured, right? So circuit breaker, routing, microservices it will use, then microservice will connect to database, then response, and I can go to the gateway and the client. So what are the security based practices? How we have to ensure that the security will be maintained for our services. So always use HTTPS between client and gateway. Validate JWT tokens at the gateway. Avoid exposing internal microservice URLs, Add course configuration where needed. So course policy will be there. Apply rate limiting to public APIs. Otherwise, it will be flooded with a lot of requests and other service will break. Centralized logging and monitoring will be centralized, so it will be easier and for debugging also it will be very useful. So propagate the tracing headers. What are the headers will be there? So it will be uh, okay. We'll go for the next slide. Here we have mentioned very few interview questions like that may asked into the interviews. Why use an API gateway? The mostly commonly asked questions. So the answer will be like to provide a single entry point that handles routing, authentication, logging, rate limiting, and other cross-cutting concern centrally. So it will be like for creating for each services we can use it centrally here if we have implemented the API gateways. So this one also sometimes it will be asked like why Spring Cloud Gateway preferred over Joule. It is because the Spring Cloud Gateway is reactive and non-blocking, better performance with the NetT, built on Project Reactor, and actively maintained for modern Spring applications. Then question 3 is what is the difference between global filter and the gateway filter? Global filter will be applies to all routes and used for common logics. And the gateway filter will be like applies to specific routes and used for route specific logics. Uh, then for the load balancer, what is load balancer? It tells the gateway to use a load balanced service name through a service direct discovery mechanism instead of a fixed URL so that it will go for the particular instance. Okay. So the next one is can gateway perform authentication? So like they will ask where we implement the authentication for our application. So you can say that like in gateway API gateway layer, the authentication will be used. Yes, it is a common practice to authenticate requests for examples, validating JWT tokens at the gateway before forwarding them to downstream services. So the validation authentication will happen here. Uh, Thank you. We'll discuss more on each API gateways in other videos. Thank you.